So Rutherford was able to figure out, based on his study of hydrogen, that there was a particle in the nucleus that he called a proton. The proton had the same charge as an electron, but opposite in sign. So protons have a charge of +1. And he figured out that they had a mass of approximately 1 AMU. Since protons and electrons have the same charge, for the atom to be neutral, there must be equal number of protons and electrons. And that is something that is still true to this day. Now, once he got above the hydrogen atom, he had a few issues. For example, the beryllium atom. Could it really have 4 protons really that close together? Because protons repel one another. And if a beryllium atom has 4 protons in its nucleus, then it should weigh about 4 AMU. But it actually weighs 9.01 AMU. So where's the extra mass coming from? Rutherford proposed there was another particle called a neutron, which they actually did find. Neutrons have no charge, but a mass of 1 AMU. And neutrons are key in keeping protons together. So here's the modern atom as we know it today. For chemists, there are 3 main parts of the atom that we care about: the electrons, the protons, and the neutrons. The nucleus, the central, dense, tiny part of the atom, contains protons and neutrons, and the nucleus is about 1/10 trillionth of the diameter of the total atom. Electrons move extremely, extremely quickly. They're held onto the nucleus through the attractive force between negative and positive charges, and they're an average distance from the nucleus of about 10 to the -8 centimeters, which is very, very small, but it's about 100,000 times larger than the radius of the nucleus. So most of the atom really is empty space. The electrons are moving really, really, really fast, and because they're moving fast, the atom has kind of a hard property to it, kind of like a fan. When the fan is going on, the fan blade is moving so fast that it looks solid. So it's the same thing with electrons. They're moving so fast that the atom appears to be solid. Now we've got to remember this throughout chemistry. Electrical charge is a fundamental property of protons and electrons. And electricity is actually due to the movement of electrons, and the movement of electrons has to do with protons. Positively and negatively charged objects attract each other, like charged objects repel one another. So positive and positive repel, negative and negative repel. And when a proton and an electron are paired, the result is a neutral charge because they have equal amounts of charge. +1 for the proton, -1 for the electron. So let's take a look at what we know now about the proton, electron, and neutron. Here are the masses in grams, and you can see it's a little unwieldy, 10 to the -24 grams. It's a lot easier to talk about the mass of protons in terms of AMU, 1.0073 AMU for a proton. Protons are always found in the nucleus. They always have a +1 charge, and here are some symbols that are used to represent protons. Electrons have a much smaller mass, and we've kept the power of 10 constant here so you can actually do a comparison. Much, much smaller than the proton or the neutron. Mass in AMU, again much smaller. The location in the atom is outside of the nucleus. It is moving quickly, and the electron determines the volume of the atom. Its charge is -1, and here are its typical symbols. Neutrons, similar in mass to the proton. It is also in the nucleus. It has no charge, and here are the symbols that are often used to describe it. Okay, so pause the slide, read these questions, and answer them as true or false. So an atom has 20 protons. In a neutral atom, it will have 20 electrons. That's going to be true. If it has 20 neutrons, its mass will be approximately 40 AMU. That is also true. If it has 18 electrons, it will have a net -2 charge. This is actually false. And let's think about this. If each proton is positively charged and there are 20 protons, then we're going to have a total charge of positive 20. If we have 18 electrons, we're going to have a total charge of negative 18. When we add these together, we get positive 2. Anytime we have more protons than electrons, our overall charge is going to be positive. Now we're ready to talk about elements. Ooh, I didn't mean to do that, sorry. Now we're ready to talk about elements. Each element has a unique number of protons in its nucleus. In other words, it is the number of protons in the nucleus that determine the identity of an element. So for example, all carbon atoms have 6 protons in the nuclei, and if a nucleus has 6 protons, it must be carbon. The number of protons in the nucleus is so important, it's called the atomic number, because the atom is defined by it. Capital letter Z is often used to designate the atomic number. Elements can be identified by its atomic number. If you know the element, you can figure out its atomic number. If you know its atomic number, you can figure out the element, as long as you have a periodic table with you. Each element not only has a unique number of protons, but they all have their own name and symbol. A symbol is either 1 or 2 letters. There will always be only one capital letter. So take a look at the periodic table, either on the inside cover of your textbook or if you've printed one from the web. All periodic tables are going to have these 3 essential pieces of information, and some of them may contain other bits of information, such as the name. However, these 3 pieces are always present. The whole number that is written is the atomic number. That's Z, or the number of protons in the nucleus, which is also the number of electrons in a neutral atom. The elemental symbol will always be there, and then this is the atomic mass. The atomic mass will have a decimal with it usually. And notice that there is no unit written here. And we'll see why when we get to later chapters, why no unit is written here. So if you have a periodic table and you know that an atom has 79 protons, it must be gold. If you know that you're dealing with silicon, then you know it must have 14 protons in its nucleus. So pause the slide and with your periodic table, see if you can answer these questions correctly. Okay, so what's the atomic number of boron? Well, according to the periodic table, it's 5. What's the atomic mass of silicon? 28.09 AMU. Now, I didn't tell you what the units were, but when we're looking at the mass of one atom, our units are going to be AMU. How many protons does a chlorine atom have? 17. How many electrons does a neutral neon atom have? It has as many electrons as protons, which is 10. Will an atom with 6 protons, 6 neutrons, and 6 electrons be electrically neutral? And the answer is yes. And by the way, this is the C12 atom. Will an atom with 27 protons, 32 neutrons, and 27 electrons be electrically neutral? And the answer is yes. What determines whether something is electrically neutral is the number of protons and the number of electrons. Neutrons don't have a charge, so if this is equal, there is no charge. Will an atom, let me get rid of this thing here. How do I get rid of this? Okay. Will an atom with 10 electrons be electrically neutral? And the answer is no, because the sodium atom has 11 protons. So for it to be electrically neutral, it needs 11 electrons.